Alright guys, welcome back. We're going to look at some more trinomial factoring. We're going to do part 2 today and actually put it together. So we kind of learn and practice. First, do a couple practice for me. Work those two out, and then I'll come in behind you. So you're trying to find two numbers. This is the same game we did yesterday and in class this morning. They're going to add to -8, and they're going to multiply to 7. So what two numbers, we could even write it out like this. What's going to add to -8? And then those same two numbers are going to multiply to 7. Start with your factors for that product, for that 7. Go. All right, let's dive in and see. Remember, I want to start with the 7, and that one's pretty easy to start because it's a prime number, meaning it doesn't have any factors. So all we've got is 1 and 7, 1 times 7. So we know right off the bat, that has to be what happens. It's 1 and 7, which does make 7, but when we plug those in for the 8, we can see 1 and 7 don't add to -8, which means we've got to flip those signs, okay? Because two negatives will also multiply to make a positive number. They'll cancel, and in the addition, it works things out to make a -8 work. So there we go. 1 and -7 are our two magic numbers there. All right, second one. If you haven't done that, pause it. And if you have, let's work that one out. So again, I'm going to factor what it multiplies to. I'm looking for that product. What are the factors of that 8? Could be 1, 8. Could be 2, 4. It's a pretty short list. And again, my signs tell me on this one, if it's a negative that I'm multiplying to, there's got to be a single negative in that pair. So it could go either way with multiplying, so it's really the adding that's going to tell us the sign. So if we need to add to -2, the 1, 8 are either going to add to a 9 if they're the same sign, or a 7 if they're opposite signs and they subtract from each other. So we know it's not going to work that way. It's got to be a 2, 4. Okay, and just a little side note. Here's what I'm saying with the 1, 8. If I have to have a single negative in there, that's going to become 7. And if I switch the negative to the other side, that's just -7. So if I know there's a negative involved, it's the difference between the two numbers, 1 and 8, and that won't make 2. So I know it's a 2, 4. And now I just check my signs. It's got to end up as a -2, which means I've got to have the negative on the bigger number so that the number stays negative. That tells me where that negative's got to go. So it's going to be -4 and +2. Those will add to a -2. They'll also multiply to a -8. So that's the two numbers that will work. Now, what is this skill we're working for and learning? Let's see. All right. This should look familiar. Don't worry about that right side. We'll get there in a sec. This is the outcome of a FOIL problem, right? This is just when we multiply out and then we combine our like terms. And remember, if we don't see anything here, there's always our friend, the invisible 1 right there. So it's x squared plus 1x minus 12. So if we go over here, it says that trinomial factoring, which is the method we're learning today, it's when we break down a trinomial into its factors, okay? So notice this is just like our GCF factoring. In the GCF method, we're breaking down each term individually into their factors, whatever multiplies to make each coefficient, or looking at the variables. So we're looking for the factors of the trinomial. This process ends up being the reverse of something we already know, and that's the FOIL problems. So the answer is going to look like this. It's a binomial times a binomial. Okay? So we're just undoing a FOIL problem. So when it starts down here as a FOIL problem, you guys would do your first outside, inside, last, right? We've done this a few times. And once you do that, your answer is that trinomial there. We are now going in reverse, and we're going to undo that. We're going to factor that trinomial and come back to the original FOIL problem. Okay, let's do that. So, skip to how we would get to that. So here's a different problem. There's our trinomial, and we're going to try to get him to this result. Our answer is going to be that FOIL problem. And we need to figure out what these two binomials are. We're going to fill those in. We're going to use the diamond method, which is basically just the number game we learned yesterday and just practiced a minute ago. It just gets put into this diamond to help you format it, but you already know this method because you've been practicing it. Okay, so the two numbers we look for, right, we've talked about, are when you have two numbers that need to add to something and they need to multiply to something. Well, the number that they need to add to, and actually I'm going to use a little bit of color coding here and be a good math teacher. Let's use colors. So what they're going to need to add to is this value right here. So they're adding to -7. And they're going to multiply to this number right here, the 12. And that's really all there is to it. We pull our two numbers out of those last two terms of the trinomial, and we're trying to figure out, they're going to add to that first term always, the two magic numbers we're looking for, and they're going to multiply to that last term. And so we just throw a diamond in there to kind of give you a graphic to work with, but that's the idea. Okay, and our two numbers, let's use blue. Our two magic numbers, you just fill them in right here. What are the two numbers that would add to the -7, and at the same time they're going to multiply to make the 12? And we do, we work through this just like we have before. Think about the 12 and factor him out. Well, 1 times 12, 2 times 6, 3 times 4, those are my choices. And it's a positive 12, so their signs are going to be the same, both positive or both negative. And we want to just see which of those pairs will also add to that -7. 1 and a 12 are too far apart. They're going to add to a 13, or if their signs were mixed, on 11, but either way that doesn't work. 2 and 6 could add to 8, or subtract if their signs were mixed and become a 4, also not going to work. 3 and 4 though, those will work. 3 and 4 will work. So it turns out 3 and 4 are my numbers. They will multiply to 12, but right now they don't add to the -7, so what do we need to do? We need to make them both negatives. Now the negatives cancel when multiplying to 12. They do add to the -7. And that was just a little distracting for me, probably you. And so those work. And so now, to take these and plug them into our answer, remember at the beginning of the lesson, I had this thing that said trinomial factoring where a equals 1. This is the simpler version of trinomial factoring. You guys will learn the more challenging version in Algebra 2 later. You'll see it again at some point, but we're just going to do the simpler version for now, and a is right at the front of this equation, okay? So whenever they write these without any variables, they write it like this, or excuse me, without any coefficients. And all this means when you see the equation, the trinomial written like this, a is always the coefficient value in front of the x squared, b is always in the middle with the x, and c is always the constant by itself. And so this is just the generic way to write the equation without numbers. And we're doing the version where there's only a 1 up front, makes it easier. So you'll always see the problems I give you for this unit in factoring, they'll always be just an x squared up front. They won't have a number like 15x squared or -20x squared. We'll keep it simple and just leave it as just x squared, okay? So since that's the case, our FOIL problem starts by multiplying these, and we always are going to end with an x squared on the first term. So that makes it easy. The first piece, the first term of each of those binomials is just x, because x times x, I'll multiply down here and make sure our answer works, is x squared. So that part's easy. You'll always just fill in an x for the first part. The real question here is what's going to be this next term. And guess what goes there? You probably already know. Your two magic numbers. That's the whole point of this method. Once we find our two magic numbers, they fill in the back of the binomial, and that solves our factoring problem. So, -3 and -4, and that's it. That trinomial factors into x minus 3 and x minus 4. And notice why we learned it as a game. When I do my FOIL process and keep going, x times -4 is -4x. Then I do the bottom, -3 times the x, -3x. And then the second term, -3 times -4, +12. Notice what happens. Okay? Our two add terms were in green there. So notice I'm going to add them together right here. -4 and -3 is that -7x. There's where they add to each other. Okay, then in blue, then in yellow, we talked about multiplying, and that's right here. They multiply with each other as that last part of FOIL, and that's how we find those two magic numbers. We find a way that they'll add to the middle term, and that they multiply to the last term, and then there you go. That's how you factor it. You just break it down back into those two original numbers, and it reverts or reverses the FOIL process, and we end up with the original FOIL problem. All right, what was my color coding? Green. Let's do it again. It's okay if you're not getting it yet. We're just going to go through it all again. Yellow, we'll stick with that. So, I want two numbers that are going to add to the middle value, to -6, and multiply to our last value in the trinomial, -7. And this will always be the case. You'll always pull the add from the middle, and the multiply is the coefficient that's last, okay? And now we'll just do what we always do, break this guy down. And again, that one's fairly easy because 7 is a prime number. There's only two possible numbers that multiply, 1 and 7. So right off the bat, we know our magic numbers. We just need to make the signs match, okay? They're multiplying to a negative, so we have to have one of them be negative. And we determine that by looking at this number. They add to something negative, therefore the bigger of the two needs to be the negative signed number, and that's our 7. We need to put the negative on the 7, and now it works out. 1 times -7 multiplies, makes that work, and then 1 plus -7 equals -6, so it works that way as well, and now we just write it up. X times x is the only thing that's going to make x squared, so the front of our binomials will always be that. And now we just insert our two magic numbers. Okay, so our two magic numbers we can see are the 1, it's a +1, and the -7. And then just to clear it, to repeat it, clarify anything you might need, if I FOIL this out, x times x, x squared, that's always going to be that front term, and then just keep going. X times -7, and then go to my rest of my FOIL. That second term, 1 times x is just x, and 1 times -7, -7. And now we can see the adding piece of my two numbers is right here. -7 plus x is -6x. That's why we needed to find something to add to -6. And then right here, the -7 is when they multiplied this second arrow here. And that's where we got the second value we were shooting for to create the magic numbers. And there you go. That's it. That's all there is to trinomial factoring, as long as there's 1 up front or no coefficient besides 1. All right, why don't we work through this one together? We'll do a we do before I have you do one. So to start, get your problem copied, get your diamond drawn up, and go ahead and fill in what are the numbers. What are you trying to add and multiply to? Okay, pull those out of the trinomial and fill those in there real quick. Okay, you should be pulling out the -8. They're going to add our two magic numbers, the two numbers that factor this trinomial. They're going to add to -8. They're going to multiply to 15. So go ahead now and take a minute and work on finding those two magic numbers. Remember, start with a list of the factors for that product of 15. Go. Okay, hopefully we've got 115, 3, 5. That's really it on this one. Pretty simple. And because it's a positive 15, we know that the signs will be the same. So one way to know the signs fairly easily is just look up here. They have to add to a negative. Anytime the signs have to be the same, you know the signs are just going to be whatever they add to. If they're adding to a negative, they've got to both be negative. So go ahead, that should be enough. Figure out your two magic numbers and go ahead and finish by writing up the factored form. It should look like a FOIL problem. Go ahead and finish. All right, hopefully we're seeing it's got to be an obvious 3 and 5. 1 and 15, if you add them, will make a 16. But 3 and 5 makes an 8, so it tells us it must be 3 and 5. And because it's a -8, I'm going to make them both negative. That'll work out for the multiplication, because a negative times a negative cancels. And when we add them, it'll work out two bad guys, make a bigger group of bad guys. It all works out. They're going to go right here. There's my -3. There's my -5. And then you're just copying down this x. The x squared just brings an x on the front and an x in the back. And again, if we FOIL this problem and do all the multiplication, we're going to end up right back here where we started. Good job, guys. Hopefully you're getting it. Now this is a you try, so you go ahead and work this one out. I'll come behind you, and we'll see how we did. And of course, if you're still struggling, work it out with me. Do it as another we problem in a minute as I start working through it. Go. Okay, if you are still struggling, you can pause at each step and I'll let you work through it as a we problem with me again. If you got it, just watch through and see if you did it right. Okay, I'm going to look for what they're going to add to, which is right here. And notice, by the way, I don't use the x. The x doesn't matter. That just comes as a factor of working through the FOIL problem in the end. I'm only looking at the coefficient 3. I didn't point that out before. Ignore the x, you're just pulling that coefficient 3. And I'm looking what I'll multiply there, and don't forget your sign. The signs always need to go with these values. Okay, so now, what are your factors? Pause it right now if you're working with me. Otherwise, I'll keep going. Pause it otherwise. 1 and 18. And since this is a negative, I know they're going to be mixed signs, which tells me it's going to be a subtraction of the two. It's going to be good guy, bad guy. And those are going to make a 17 when I subtract them either way. Positive or negative 17, not going to work, so I'm going to keep going. 2 and 9, when I subtract those, will make a 7, either a positive or negative 7, not going to work. How about 3 and 6? Okay, 3 and 6 are what I'm looking for. That's the factor pair I need. And now I just need to match the signs up. The way to do that, this 3 is positive. That means the larger of the two numbers needs to also be positive. That tells me I need to have the sign on my negative right there, or excuse me, on my smaller number, my 3. And now when I multiply, that is going to multiply to a -18 with that single negative. And when we add them, that positive 6 is the larger group of bad guys. It's going to make that 3. And there we go. Write up your final answer. We're going to have that x for the front term, and then we're just copying these guys over. No, a little better arrow there. And there you go. All right, here's your homework, guys. 4 of these trinomial factoring problems with your little diamond grids there. If you are starting to get the hang of this and understand that you're adding to that middle term of the trinomial, multiplying to that last term, you can dispense with the diamond. You don't have to draw up the diamond, but I'm just keeping it in place right now to help you out. I'll go ahead and fill these 4 in afterwards to give you a check on your work and see how you did. Go ahead and pause it, do the problems, and I'll come behind you and fill in the solutions. Go. All right, let's do it. Okay, 10 is going to be a 2, 5, or it's going to be that 110. I'm thinking it's 2, 5. And since they're both negative, they have to be negative 2 and negative 5. To add to that negative 7, always x is up front, so we end up with an x minus 2 and an x minus 5. And there's our factored pre-FOIL answer. All right, next one over on the right here, there's always that invisible 1 there, so my numbers need to add to 1. They need to multiply to that negative 56. So when I start factoring that out, I know it's 7 times 8. And I was thinking, I think that's it that I can think of. You could break down that 8 into some, like a 4 and a 2 and recreate it as like a 14 times 4 or something, but probably 7 times 8 is the one we're going to land on. And if I check it, it looks like that's the one that'll work anyway. Now, because it's a negative 56, I need a negative somewhere, and because it's a positive 1 the answer ends at, then my bigger number needs to be positive, therefore the other number, the smaller one, has to be the negative. And so there we go. It's an x minus 7 and an x plus 8. There we go. And remember, it's always just going to be an x up front with this type of trinomial. All right, next. Adding to the 8, multiplying to that negative 9. If we factor that guy, we've got the 1, 9, or we've got the 3, 3. 3 times 3, hopefully we can see whether we add them or they have a mixed sign and subtract. Either way, they're not going to come out to 8. They're going to come out to 6, or they're going to go to 0. So it must be 1, 9. And again, the mixed sign here, because they're multiplying to a negative, and I've got to put the negative on the 1. This is just like the other problem. So we end up the same way with the negative on the smaller number. So it adds to that positive. X minus 1 and x plus 9. By the way, if anyone had an answer about what if I wrote them or rewrote it this way, if I had my numbers reversed, and that's fine. It doesn't matter because in multiplication or FOIL, you're going to end up back at that trinomial either way. So those are both correct. It doesn't matter which order you write those numbers in. All right, final, let's see, multiplying 6, 5 is the first thing I think of with 30, and to be honest, that looks like it'll work because those make 11. And they need to add to a negative, which means they both need to be negative themselves, and when they multiply, it'll cancel to make positive 30. It all works out. So we got x minus 6 and x minus 5. All right, hope you guys did well with that. See you tomorrow in class.